Welcome to this professional development resource on velocity-based training, or VBT. VBT is an auto-regulatory method for prescribing barbell exercise intensity and monitoring the execution of these exercises, and it's a useful tool to add to your toolkit as an exercise scientist. In this presentation, we'll be touching on what it is, how it's measured, and a few equity considerations to keep in mind when working with diverse clients. Velocity is just the speed at which something moves. When we lift weights, we know that the heavier the resistance relative to our level of strength, the slower the weight moves. Additionally, over the course of a set, the velocity of the bar slows down rep to rep as your muscles fatigue. Therefore, we can measure the velocity of the bar during barbell lifts to infer the difficulty of any given rep, provided that the athlete moved the bar as fast as they possibly could, which is usually the goal during barbell training. This means that VBT is useful for powerlifting, that is, the squat, bench press and deadlift, Olympic weightlifting, the snatch and the clean and jerk, or any other barbell exercise used to develop strength, power, hypertrophy or athletic performance. In fact, every exercise has a unique load velocity profile, which is the typical relationship between the relative load and the speed of the bar during that exercise. We can pull a few key metrics out of a barbell's velocity. The first is simply mean velocity. We're usually only interested in the concentric phase of the lift, so this just means the average speed of the bar during the lifting phase of the rep. We can also look at the peak velocity, which is the fastest velocity achieved at any single moment during the concentric phase. Finally, mean propulsive velocity is the average speed from the start of the concentric phase until the bar's acceleration is less than the acceleration due to gravity. This is a less common metric, generally used for very explosive exercises like submaximal Olympic lifts. There's a lot of methods for prescribing and monitoring resistance training, but VBT has certain advantages over all of them. Let's use the back squat as an example. The simplest method would be to directly prescribe a load to your clients, but this makes it hard to tailor the prescription to each individual, who all have different levels of strength. VBT is individualized, meaning we can fine-tune an exercise's load velocity profile for each lifter through testing, and then prescribe target velocities instead of target loads. Another option would be to test your client's 1 rep max for their squat and then prescribe different percentages of this max. This is more individualized, but it doesn't account for day-to-day variations in performance. Your client could be particularly fatigued one day, meaning the weight they can squat for 6 reps that day is a lower percentage of their 1 rep max than it would be when they're fresh. By targeting a velocity instead, the right intensity is always achieved, even when the load needs to change. This means that VBT is auto-regulatory. In other words, it automatically regulates your training load based on your capacity on the day. The other common method of auto-regulation is using subjective measures like rating of perceived exertion or repetitions in reserve. By targeting a specific difficulty on a scale of 1 to 10, for example, the right intensity is achieved even when the load needs to change day to day or week to week. However, because these are subjective measures, they're prone to human error, where the difficulty of a set is under or overestimated. Since VBT relies on objective data instead, it's much more reliable. The final benefit of VBT is that it can gamify training. Because the lifter gets real-time feedback on their performance in every rep, they're often intrinsically motivated to move the weight with more intent, either to stay above a threshold or break their velocity records. Distinct velocity zones are sometimes used when prescribing bar speeds. For example, anything under 0.5 meters per second might be considered optimal for absolute strength development, while anything over 1 meter per second might be used for speed and agility training. However, the concept of velocity zones has been criticized, with research suggesting that these distinct categories are largely unrealistic. A more accepted technique is the use of velocity loss thresholds. Since each exercise has a typical minimum velocity before failure is reached, the magnitude of velocity decrements can indicate proximity to failure. Velocity loss thresholds are used to terminate a set once the velocity has decreased by a given percentage from the first rep. Different cutoffs are used to achieve different outcomes. For example, a lower threshold like 10% might be used to minimize fatigue during plyometric training, while a higher threshold like 40% might be used to promote muscular hypertrophy. There are a few ways to track barbell velocity. The most common is using a device you attach to the end of the barbell called a linear position transducer, which measures the velocity relative to a fixed reference point. Some of these devices, like the Tether by Rep1, use a cable running from the barbell to the ground to track the position of the bar. Other devices, like the GymAware Flex, bounce an infrared light off a reflective mat to measure their distance from the ground optically. Linear position transducers are usually very accurate when compared to a gold standard reference like 3D motion capture. Alternatively, inertial measurement units, or IMUs, use onboard accelerometers to track the barbell's acceleration and then derive velocity. These are convenient because they don't require a cable or a reflective mat, and they're also mostly valid and reliable. The final option is to determine barbell velocity using a video of the lift. There are some dedicated devices that do this quite accurately, like the Perch, which sits on the rack and uses cameras and depth sensors to track the bar. Even more accessible, though, are smartphone apps like Metric VBT that use AI to estimate velocity from a video taken on your phone. These are convenient for barbell athletes who often film their sets anyway, but unfortunately at this stage they're much less valid and reliable than hardware solutions. Devices that track barbell velocity are useful, but they can be inaccessible. The most accurate ones, like linear position transducers and IMUs, cost hundreds of dollars per unit. This makes them simply too expensive for many people, especially those of lower socioeconomic status. Even many coaches, community gyms, or grassroots sporting organizations might not be able to afford velocity trackers for their clients, members, or players. There are, however, a few solutions to ensure that everyone has access to VBT. Where feasible, the coach or gym could provide a velocity tracker to use during sessions. But unfortunately, this isn't always possible, and it restricts the client from using VBT when they're not with their coach or when they're training elsewhere. Even though they're not as reliable, velocity tracking smartphone apps are much more inclusive of those who can't afford a standalone device. Many of these apps offer a paid subscription to access all of their features, but even the free versions are usually enough to reap the benefits of VBT. Even without a dedicated app, it's possible for coaches to manually calculate barbell velocity from a video using 2D biomechanics software like Canovia, but this is extremely time-consuming, especially for many reps and sets. For those who don't have a smartphone or who VBT is otherwise not a good fit for, alternative prescription and monitoring techniques are still very effective. Subjective methods of autoregulation like rating of perceived exertion and reps in reserve are very powerful and might be even better than VBT for some clients. At the end of the day, as long as the basic exercise principles are being met, technology like velocity tracking is a more advanced training method that can be useful to optimize the last few details of a training program. So clearly there are a few challenges to consider when deciding if VBT is right for you. It's an advanced technique, so there's a pretty steep learning curve for the coach and for the client. There's also a lot of devices or apps to choose from, each with their own pros and cons. Finally, some people can actually get overly invested in barbell velocity, losing sight of the bigger picture. This could lead to clients or even coaches chasing faster lifts instead of better lifts, and it's not hard to imagine the quality of execution breaking down if bar speed is prioritized above all else. With that being said, when used correctly, VBT is the only objective and individualized method of autoregulation. For the right coach and the right client, it can be a great option for exercise prescription and monitoring. However, it's important to consider equitable solutions to ensure everybody can access the benefits of VBT when working with diverse clientele. There's been a lot of research on VBT in recent years, and there's a huge number of educational resources on the internet. If it sounds interesting to you, I strongly encourage you to learn more and play around with tracking barbell velocity using one of the free apps.